Have you ever wondered how giants like Google build machine learning systems that actually work at a massive scale, for millions and millions of users? Well, spoiler alert, it's not about jumping straight to the most complex algorithms. Today, we're going to crack open Google's internal playbook and look at the real rules for building ML systems that are reliable and efficient. Let's dive in. Now, all the incredible insights we're covering today come from an adaptation of Google's famous Rules of Machine Learning, which was put together by Jorge Ivan Pinca Pons. If you want to go even deeper and check out the original source material after this, don't worry, we've got you covered. All the useful links are right there in the description. So what's the secret sauce, right? What do Google's top engineers know that maybe the rest of us don't? Well, today, that's exactly what we're going to unpack. We're skipping the fluff and getting right to the core principles that really drive success in the real world. Okay, first up, the playbook itself. Before we even think about writing a single line of code, we have to understand the strategy. This is the bedrock, the foundation for absolutely everything that's going to follow.
Before we go any further, let's just quickly get on the same page with a few key terms. Think of it like this. Let's say we want to predict if an email is spam. That email, that's the instance. The correct answer, spam or not spam, that's the label. A feature could be something like whether the email contains the word free. Then we train a model to make these predictions, and the whole system that feeds it data and gets the answers out, that's the pipeline. Simple, right?
Now, here is a really key insight from Google. Building a machine learning system isn't just a one-and-done kind of thing. It's a life cycle. It's a journey. And we're going to walk through the 4 distinct phases of that journey, from a simple idea all the way to a complex, always evolving system. Phase 1 is all about laying a rock-solid foundation. I know, it's so tempting to build the fanciest, most complex model right out of the gate, but honestly, that is a classic mistake. The rule here is simple. Start simple. First, nail down your metrics. Get your data pipelines working perfectly with just a basic model. Only then, once that's solid, do you even think about adding complexity. So, once you have that simple system up and running, your focus has to shift to monitoring. And there's a huge danger here called the silent failure. This is when your system is technically running, but the quality of its predictions is slowly, quietly getting worse. And that is exactly why you have to start with a simple, interpretable model. It just makes spotting these sneaky problems so much easier. All right, now we hit phase 2, feature engineering. You've got a solid infrastructure, so the name of the game is rapid iteration. You're constantly adding new features, trying to make the model smarter. But, and this is a big but, here's a critical warning. Your intuition as an engineer can be totally misleading. You have to remember, you are not a typical end user, so you have to rely on the data, not just your gut feelings. In phase 3, we start to tackle the really, really tough problems. And maybe the biggest one is something called training serving skew. The best way to think about it is like a student who gets perfect scores on all their practice tests at home, but then completely bombs the final exam. Your model might look amazing during training, but it performs poorly in the real world. This is also when you learn that when you hit a plateau, the answer isn't just tweaking the model, it's about finding completely new sources of information. Okay, enough theory. You've seen the rules, you've got the playbook down. Now, let's put it to the test. Let's see if you can apply these principles to some real-world scenarios. You ready for a little quiz? Okay, scenario 1. A team wants to improve product recommendations, so they jump right in and start building a super complex model using every piece of data they can find. What fundamental rule are they breaking here? And the answer is B. This is a classic violation of rule number 4, keep the first model simple. If you start with all that complexity, you'll never know if a problem is coming from your model or from your basic infrastructure. You have to get the foundation right first. All right, scenario 2. A movie rental service tries to save time by just copying their pipeline for existing users and using it for new users, but it fails immediately. Why? Because the pipeline drops anyone without a rating history, which of course is every single new user. What's the mistake? The answer here is C. This is a perfect example of Rule 6, and it's a trap known as cargo cult programming. That's when you copy something without really understanding the hidden assumptions behind it. In this case, the fatal assumption was that every user already has a rating history. Whoops. On to scenario 3. Your virtual cooking assistant app isn't crashing or showing any errors, but all of a sudden it starts recommending really bizarre recipes. Technically, the system is still working, but the quality has just tanked. What do we call this?
Yep, this is a textbook silent failure, and it is exactly why Rule 10 is so critical. A system can be running perfectly from a technical standpoint, but be completely failing its users. This is why you need metrics that track not just if this system is on, but the actual quality of the results it's producing.
Okay, time for a quick true or false. Can you take an old, simple business rule, what we call a heuristic, and turn it into a feature for your new, smarter machine learning model? True or false? The answer is a resounding true. And this is the absolute essence of Rule 7. Don't just throw away your old business logic. By turning that heuristic into a feature, you're actually giving your new model a massive head start based on proven real-world intuition. Okay, last scenario. Imagine a user who loves action movies on Netflix, but on Hulu, they only watch comedies. A model that was trained only on their Netflix data completely fails to recommend good comedies on Hulu. What does the situation tell us? The correct answer is C. And this is such a subtle but incredibly important insight from Rule 43. A person's interests are contextual. A person's identity is stable, but what they want, that depends entirely on where they are. A truly intelligent system understands that context is everything. So after going through all these rules and all these different scenarios, what's the one big thing you should take away from all of this? It really all comes down to this. Building an ML system is a lot like building a skyscraper. You can dream up the most beautiful, advanced, futuristic design in the world, but if the foundation, your data, your infrastructure, your core engineering principles, if that foundation is weak, the entire thing is worthless. Solid engineering always has to come first. And that's a little peek inside Google's machine learning playbook. Thanks so much for joining us for this explainer. If you found this useful, a like, a follow, or a share is always hugely appreciated. We'll see you on the next one.